now that you have a general understanding of transformations and the different types of functions there are, we looked at all our parent functions, we're going to spend some time looking at each function more specifically. So the next group that we're going to look at are polynomial functions. The most basic of a polynomial function is our quadratics, so we're going to start there. Quadratic, remember, is our f of x equals x squared. When we're talking about its most basic form, our parent function for quadratics is just x squared. And we also talked about the shape of that graph when we talked about transformations. So we know that the graph of x squared is a parabola centered at the origin. So it looks like this. Just to review, if we're talking about the domain of a parabola or a quadratic parent function, from left to right we have everything from negative infinity to positive infinity. Our range starts at 0 and goes up to infinity. Remember, that's my y values. My x-intercept is where I touch or cross the x-axis. When I write my x-intercept, I'm just going to use the x value there. So my x-intercept is at 0. I'm increasing everywhere that my function is going up. So I'm increasing from 0 to infinity. I'm decreasing everywhere my function is going down. So I'm decreasing from negative infinity to 0. My vertex is that min or max point of my parabola. It's that point that kind of centers the parabola. It's either the bottom of it or the very top of it. In this situation, my vertex is right here. So my vertex, when I label my vertex, I'm going to use coordinates. So my vertex here is at 0, 0. And I want to use coordinates to label. If I'm looking at my vertex, I see that it's the lowest point on the graph, so I know that means it's a minimum. And when I label my minimum, I just use my x value, remember, so my minimum is at 0. So my domain again, left to right. My range is low to high. My x-intercept is the x value where we cross x-axis. Increasing is where I'm going up, decreasing is where I'm going down. And these are going to be both going to be x values. It should all be a review. So now that we've kind of dusted off our knowledge of our parent function for quadratics, we're going to start looking at graphing quadratics without using a calculator. So I can give you, for example, two functions. My first one is g of x equals x squared plus 1. My second function is h of x equals x plus 2 squared minus 3. So if I'm going to graph these, we already know what is happening here from our knowledge of transformations. So if I look at this first one, if I look at g of x, I know that this plus 1 outside the parent function at the end of the equation takes the parent function and moves it up 1. So if I had my parent function, I have my parent function, which is just x squared. I want to physically take the vertex and move it up 1 point and redraw my graph. This would be my g of x. I'm going to do the same thing for the second one. The plus 2 on the inside of the parent function is going to move it left 2. The minus 3 on the outside is going to move it down 3. So again, I like to always draw my parent function first and then physically move the vertex of my parent function to its new location. So my parent function starts at 0, 0. And then I want to take my vertex and I want to move it left 2 spaces. 1, 2, and then I want to go down 3. 1, 2, 3. So my new parabola starts at -2, -3, and then I'm going to redraw it from there. So another thing that I've kind of noticed right away was that my vertex here is -2, -3. My vertex of the first one is 0, 1. My vertex shows up in my equation. I know where I'm going to plot the vertex because of the numbers that are in my equation. And this is called the standard form of a parabola. So when we talk about the standard form equation, I have f of x equals a times x minus h squared plus k, where h and k are telling me my vertex. My actual vertex of my equation is going to be h comma k. So you can also, if you forget about transformations, which would make me really sad, but if that did happen, you could just pick out the vertex from the equation by picking out your h value and picking out your k value, plot your vertex, and then go from there. So remember, your vertex is either your lowest or highest point on the parabola. So you could, if you have an upwards facing parabola, your vertex is going to be the lowest point. If you have a downwards facing parabola, your vertex is going to be the highest point. Your x-intercepts are where the parabola touches or crosses. Crosses the x-axis. So you can have a couple situations here. You can have a parabola, standard parabola, where you're going to have 2 x-intercepts. You can have a parabola that just kind of sits on the x-axis, in which case you're only going to have 1 x-intercept, or you can have a parabola it's kind of floating up above the x-axis or down below it, and this doesn't have any x-intercepts because it doesn't touch the x-axis at all. So you could have none, you could have 1, or you could have 2. You're also going to be telling me where your max, whether your vertex is a max or a min. And remember, max is the highest point, min is the lowest point, and you're going to use your x values to label them. So if you have a parabola that's facing up, your vertex is a min. If you have a parabola that's facing down, your vertex is a max.